To introduce our next panel, Applied MOSA Architecting for Change, we've got Ms. Nadine Geyer will be moderating. Nadine is the Director of Systems Engineering within the Department of Defense Office of the Executive Director of Systems Engineering and Architecture. Ms. Geyer manages the department's efforts to implement modular open systems approaches across DoD and other government agencies. She's also the government program manager for the DoD Systems Engineering Research Center, a consortium of U.S. universities conducting research to address systems engineering challenges critical to national security. Nadine has more than 30 years of experience working with DoD and industry acquisition programs in the areas of explosive ordnance neutralization and disposal tool development, nuclear weapons systems management, weapon system inspection and certification, systems engineering, product assurance, foreign military sales, shipyard launching systems, installation and repair, and technical manual development. So, Nadine, I turn it over to you.
Okay, thank you. Can you hear me? Okay, good. So, I won't introduce myself. He did an admirable job doing that. I will introduce my esteemed colleagues. Lieutenant Colonel Breen. He is with the PEO Ground Combat Systems. For his most recent experience, he has rotated through various staff assignments prior to coming to PEO Ground Combat Systems in 2019 and is currently serving as the product lead for ground combat product integration, managing the development of network integration modernization strategy, the platform battle management system, and related integration of mounted capability set hardware and software. He's received numerous awards, including the Meritorious Service Medal, the Army Commendation Medal, the National Defense Service Medal, the Iraq Campaign Medal with Bronze Service Star, the Global War on Terrorism Service Medal, Outstanding Volunteer Service NATO Medal, the Army Staff Badge, Army Parachutist Badge, and Chilean Jump Wings, which is very impressive to me. He has received his Bachelor of Science in Political Science and Philosophy from the University of Nebraska and received a Master's in Liberal Arts from the Johns Hopkins University in Baltimore. Welcome to the panel. Mr. Alan Cichosz, is currently serving as the Chief Architect for Product Lead Capability, Transition, and Product Integration, also with the Ground Combat Systems in Detroit Arsenal, Michigan. He previously served as the Senior Fellow with the ASA ALT Chief Technology CTO Office to lead the development of an open architecture for OMFV and future ground systems. The open architecture ground common infrastructure architecture has been defined and released as part of the RFP and is now being managed by PLCTPI for implementation across the ground combat systems. He has previously served as the Chief Integration Engineer for Bradley and Program Manager for Leader, Follower, and Ground Vehicle Robotics at DevCom. He holds a bachelor and master's degree in mechanical engineering from Wayne State University, along with a master's of business administration from Lawrence Technology University. And then finally, we have Mr. Stough. He is the Chief Architecture Officer for JHNA and the Chairman of the Aviation and Missile Technology Consortium Executive Committee. He has more than 25 years of professional experience that includes a unique mix of technical and leadership roles in multiple industries from aviation, industrial controls, robotics, 3D visualization, missile defense, and active duty service in the U.S. Air Force. He was elected by his peers in the aviation industry to serve as the board of directors for the Vertical Lift Consortium and has spoken at several national conferences on open architecture. His consultations on architecture for the MOSWIG, which is near and dear to my heart, and an international team such as the Collaborative Open Systems Architecture Project. He currently supports the U.S. Army Executive Program Office for Aviation as an architecture subject matter expert. Prior to this, he supported the program managers for Future Vertical Lift and utility helicopters. John holds a Bachelor of Science and BAMIS. I'm not familiar with that. Ah, from Columbia College, and has a number of professional certifications. Thank you all for joining the panel. Um, the ground combat systems will start with their presentation. I'm sorry, I'm not close enough. The ground combat systems will start with their presentation, then we'll move on to Army aviation.
All right, thank you for that introduction, Nadine. So again, I'm Alan Cichosz. I'm Chief Architect for PLCTPI out of PO GCS, and joined by Lieutenant Colonel Breen. And thank you for having us. We're here to kind of share kind of what we're up to in PEO GCS in terms of implementing um, a modular open systems approach, and getting after what, like Mr. Howell said, how are we updating at the speed of relevance? And a lot of that has to do with adopting standard-based approaches and re-architecting our platform. So, want to kind of introduce who we are within the PEO and our approach to architecture, and then sort of our strategy, how we're approaching it, and so I hope you all can find it useful. All right, next slide, please. I think we got the wrong. That's the right title chart, but wrong deck. There we go. Okay, perfect. So let's go back one more. Perfect, right there. Yeah. So our office, we are the our office is called Project Lead Capability Transition Product Integration. So we are a newly minted project office within PEO GCS. This is a '06 office. It's Mr. McNeil is the project officer. But it was stood up within PEO GCS to look at horizontal and vertical technology integration. It's focused on integration across platforms and bringing a lot of these technologies, through maturity to be transitioned onto the platforms. So there's 3 offices within there. There's the combat product integration, the combat enabling technologies and transition, and then vehicle protection systems is also under that group, given that those protection systems go across platforms. Go to the next chart. So kind of getting at our architecture objectives. The big one up front is ensuring consistent MOSA implementation, both within and across platforms. And I'll talk a little bit more about that. We'll get more into depth, but basically, instead of just going on contract saying do MOSA, that can be done in many different ways. So we need to provide additional definition on what do we mean by MOSA, how are we breaking up our systems, what standards apply in different areas. So that's what we've done with this architecture effort. But obviously reducing time and cost to add upgrade capabilities, both on a platform, but also across platforms. So if we develop something for one, we want to use it across all of them. We're enabling development and integration of solutions at the hardware and software component level versus entire subsystems. We're not buying full systems, we're buying pieces. And then reducing the need to retest the entire system each time a new component is added or changed. So I think you also see some similarities between what we're doing and what was shown with UMA with unmanned maritime systems. All right, so kind of starting out, it's really a paradigm shift. So we're actually making a big transformational shift with ground systems. So even going this route, this is not going to be easy, and we don't expect it to be easy. But we need a big transformational shift in order to achieve what we want to do. And like I think everyone can kind of relate to our current state where our platforms, we integrate entire subsystems. Each subsystem brings its own end-to-end functionality. They're put together different ways, don't interoperate. So if you kind of picture our current platform, as an analogy, I kind of picture our current platforms as a person walking around with a pager, a flip phone, a Palm Pilot, and an iPod, and that's really kind of how our systems are put together. And what we want to get to is smartphone, smart platforms. So if you look at kind of on the right, what we did is everything that's kind of common between, no matter what your capability is, like everyone needs computing, everyone needs displays, everyone needs a network. We've really flattened that structure. We're providing that at the system level. So if you notice on the right-hand side, there aren't, and you don't see any subsystems. You see a platform that has a infrastructure, and then it's outfitted with a suite of sensors and effectors. And what you do with those effectors and sensors, those inputs and outputs, is software defined. We also have a common software architecture that goes with it. So if we go to the next chart, this just shows a little bit more detail of how we kind of broke up the system. So if you kind of look at this view, it's broken into 3 layers. Um, and I'll kind of go into each one in a little more detail. But basically, this is kind of like the view of this is how we put the this is how we broke up the system, and this is how we put systems together. So if you look at everything in white, it's kind of like I don't know if you remember some of those video games where you kind of like assemble a car, like you can pick these wheels, you can pick this engine. So it's kind of like everything in white is what you'd pick to put your platform together. So starting with the bottom, first you pick a platform, and it really doesn't matter what platform you pick. And from there is when we layer on the common infrastructure. So you add the common elements that every capability needs, which is the computing, data storage, network, crew station computing, displays. And then from there you layer on what you need to do with that platform in terms of sensing, different effectors you're going to have on that platform. And those are all tied together with a common shared software infrastructure. So what then capabilities you add is purely software based. So if you put a camera on there, it's not my 360 camera. It's a camera on the platform that you might do 360 SA with, but you also might do anything else you might want to do with it. So then the final point on this slide, again, you don't see subsystems. And then even from the infrastructure up, it's platform agnostic. So what is developed for one platform, you can take and you can load it on another platform. So if someone defines a new autonomous maneuver for a platform, you can take that software, load it, and you have it across the fleet. So um, that pretty much sums up the architecture. Then I'll turn it over to Lieutenant Colonel Breen. He'll kind of talk about, okay, here's the future state. What are we doing we're not at this future state. So what's our kind of strategy to move toward that? So
Yeah, thank you, Alan. Next slide. I think somebody made the comment this morning about they were the one unlucky enough to take on the job, and somewhat of a tongue-in-cheek comment there, but absolutely a lot of opportunity to do some good and get after this problem and modernize. We talk a lot about innovation and how we're going to innovate in the DoD. It's a very rare and rewarding and challenging opportunity when you're actually put in one of those jobs that you are innovating every day when you and your team wake up and connect. So this is absolutely one of those areas. Alan talked a lot about the what being GCIA. That's that Ground Common Infrastructure Architecture, which is the ground combat MOSA, Modular Open System Architecture. That is what we are doing. How we are going to do it is what my team and I are taking on. So when we first looked at this architecture and looked at the scalability that Alan was offering and the community was offering as they put that together, we came across a couple dilemmas that we had to get our arms around. The first is you've got an enduring fleet and the momentum behind subsystems and programs of record that have been going on for decades, millions of dollars spent. You can't just shut that off and turn modernization on and claim victory and move forward. So that is a challenge we had to identify and get our arms around as we move forward. The second one is, okay, if you're ramping down or you've got to have a plan for ramping down enduring fleet, enduring programs of record, you've also got to have a plan to ramp up modernization and to get at what exactly Alan just described to us, which is that open system architecture and that scalability. And then getting the immediate needs of the fleet met is a sweet spot between those two ramping down and ramping up points we still have rollovers. We still have motor pool accidents. We still have needs of the enduring fleet that aren't just these next generation programs of record and aren't this modernization effort. You've still got critical safety things that you need to improve in the near term. So there was a kind of three-way sweet spot that we were trying to figure out how to meet. And in order to get our arms around the problem set, I think in the DoD we use the word buckets a lot. Well, how do I start to bucket my problems? How do I start to aggregate this in a way that I can get my arms around it? And what we came across in our team was an analogy. Somebody else brought up the auto industry in one of the presentations this morning, and we said, Eureka, trim levels. Exactly from the auto industry, you can go buy a base model. You can go buy a platinum limited edition that's got the latest infotainment suite, all the sensors you would want. And you can also open up in that paradigm. There's a lot of small sleight of hands that we can pull that meets the needs of all audiences. You can apply programmatic and cost benchmarks as you go. The entire ground fleet does not need JADC2. The M88 tow vehicles for the tank do not need to be equipped with JADC2. So what we've realized is, okay, a large chunk of the force will need a base or a gray capability. And the names of the trim levels, many of them were brought forward from the team. Gray, one of my guys wears one of the black KIA bracelets. Buddy of his, Staff Sergeant Gray, crushed between two tanks in a motor pool accident in Iraq, and back decades ago. And he said, "Hey sir, for that soldier safety one, I'd love to call that the Gray model." Absolutely, Jared. That's what it's going to be called going forward. And Argos, that was another one of my guys threw out. It's a 100-eyed mythical beast, only closes half of its eyes at a time. And we said, you know what? That's our JADC2 goal. So we did a goals and kind of capability-based scale using GCIA as the architecture. And no, we're not going to get to Argos and not going to get command by next year, but we can start with some base capabilities. Getting our arms around the OS problem that we've got a plethora of operating systems across the ground community, and to scale up, we know we're going to have to get our arms around that problem. Then you start to introduce soldier safety. In many instances, you're going to try to do it in GCIA, but in other instances, if you could buy a GCIA compliant camera or sensor or something along those lines, and maybe you have to do some one-off NRE work that doesn't quite fit the bill, but it does improve that platform safety, you've got a victory there, and you've threaded the needle successfully on the three dilemmas up front that we were at first talking about. And then on the ground side, we also know there is a lot of really interesting and really cool AI projects just over the horizon that we have no idea how we're going to incorporate on platform right now. And how do you make them work together? This guy in lab over here developed an AI project, and this separate lab over here developed an AI project, and how is that going to work together on platform and do all the transparent data sharing and comp sharing in the back like you want it to? Well, that's another problem set that we know as we do MOSA, as we do GCIA, and build this architecture, we can start to get our arms around. And then the other thing we'll do, and I'll kind of briefly point out, is the two projects at the bottom of the slide there. A U360 architecture, that's the one I was kind of referencing at the beginning. If we went down the path of not a MOSA architecture, but we went down the current path of how we build combat systems, ground combat systems, and you continue to go down the path of data and comms, and all these programs are going to interact with AI, we would have 50 different cameras and sensors all around the outside of the vehicle that are bespoke to a VPS pipeline, to a JADC2 pipeline, to a PPMX pipeline, to a and we knew that that was just a non-starter from the beginning. And everybody was like, "Hey, I want to figure out where to get that sensor on." Okay, first step, we need a universal 360 sensor suite. It's gonna be designed with GCIA and MOSA in mind. But as I said just a couple minutes ago, we might need to build some NRE, but bespoke solutions that are one-offs to tackle some of the gray, maybe into the combat capability. But in the platform battle management system, we are going to go a pure TMI, or that TMI will be pure MOSA, and that is an attempt. I've got another slide that's not in here, but we show the transformation of gunner stations from the ground combat systems and the aviation systems. And unfortunately, we look a lot today like we did in 1945. Aviation systems have gone from dials and switches down to a glass cockpit, and that PBMS project aims to help us deliver an Argos capability, improve that kind of air, give us the capability anyway to improve that air-ground battle, and give us the JADC2 functionality. Because without something like that, it would be very tough for us to get there today. That's the best we've come up with so far. Engineers will tell me all the time we're glossing over a lot of stuff, or what about this, or how are we going to do that, or I don't know. The engineering model is you solve the most pressing problem in front of you that you can, and you keep solving problems until you actually get the capability you want. So this is our vision and our model that we're going after, and we're trying to implement the GCIA that Alan previously briefed. Questions at the end, I guess.
Yep. All right, can we next slide, please? All right, so just kind of re-go over our strategy. So for, like we mentioned, it's a big transformational shift. So for future systems, that's a lot easier. So even with developing of this infrastructure architecture, our next opportunity is OMFV, optionally manned fighting vehicle. So there's basically a scramble for a year to put this together, and that's now a requirement for OMFV and going forward. And in that development, when we develop that, since like we mentioned, you don't see subsystems, it affects the whole platform, every functional aspect of it. When we did that, we not only do we pull the government SMEs from the different functional areas that have been working on architectures within their silos, we brought them together to define this at the system level. But also, as we did this, we posted on Beta SAM that, hey, the government's defining this for all our vehicles, and we set up a community of interest for industry to participate and give feedback as we developed it, because we didn't want to just government define something without their input. So anyway, going forward, that's the architecture, and then like you mentioned, across the enduring fleet, incrementally implementing it where it makes sense and it's practical. Our final chart is next, I think. And this was just how to participate for those who are interested in participating or learning more, or getting the artifacts from our architecture. It's through the community of interest that we've set up through NAMC. There's a link there below, and there's also I can be reached via the GCIA mailbox at the email address below. So that's it for us. So thank you.
All right, excellent presentation, guys. Thank you. And I'm gonna leverage something that I learned when I went to a comedy skit one time. They had this fun little comedy game that they played where you could never say no to the ridiculous thing that the person in front of you said. You could never say but. You could never say anything else except yes. Yes had to be the very first word that you said, and then the next word had to be and then you had to build on whatever it was. So it creates hilarious. If you're looking for an icebreaker, it's called the yes and game. You should play it. So yes, and we can't fall out of the sky. So the last thing between you and the reason you're here for defense standardization program updates is my presentation. So I'll try and be brief. I am here representing Matt Sipe. He sends his regrets. He can't make it. And because I'm a contractor, I want to put the disclaimer out there that I don't speak on behalf of the government. So if I say anything ridiculous and stupid, that's entirely on me. Next slide, please. So the important thing here is that we recognize that, as was stated, modular open systems has the architecture aspect, which we typically think of as the technical side. There's a lot of work in the technical side. However, we miss the objective entirely if we don't recognize that it's an integrated business strategy as well. That our approach to modularity and our approach to openness, which are two different moving parts, they move at different cycles, they have different objectives associated with them, they have different measurements associated with them. I measure something as modular, but it could be closed and modular, right? Your iPhone is an example of this. Um, Whereas something that is open and not necessarily modular in its structure may allow you to change it, but you may not be able to change it in very large chunks, right? So openness and modularity principles help guide where we're aiming, but we have to integrate that into a business strategy. We can't just take the technical aspects of openness and modularity. We have to take the business aspects as well. And so what we recognized, and particularly pointed out by Mr. Howell, we as a PEO are not just looking at the Title 10 requirement that says that every new system has to apply a modular open systems approach to the development of their system, but that as a PEO we have a portfolio of systems, and no two portfolios are created the same. The ground combat systems have a different the gray capabilities that were described is unique to that because you can't check out a helicopter typically from the motor pool, and so you end up with systems where your baseline capability, your baseline configuration as a completely integrated weapon system has very little in common with another program of record. Part of that is because of the way that those programs of record are funded. Part of that is because of the way that they're contracted, and so we recognize that a series of inflection points came together for the PEO to rethink its strategy associated to management of the entire portfolio. Um, Obviously, the rapid change of the threat environment and the operational environment, JADC2 mentioned, and you recognize the fact that we're moving from coin operations or counterinsurgency operations to large scale combat operations, and all of this is in the public domain, so you can go search all of that. But that was one aspect of the inflection point. Another aspect is the speed of technology change. Mentioned on an earlier panel was the idea of changing chip providers. So I'll give you something that you may not know about aviation. This is something that you can include in your evening dinner trivia. When you upgrade, has anybody? This is a functional test of your arm. Does anybody that's physically here, and if you're online, raise your hand. I won't see you, but it might be fun. Does anybody remember the shift from 32-bit to 64-bit computing, and like the software applications that you couldn't run anymore? Okay, so there are a few people older than my kids in here. So my kids don't remember this, right? But the issue is that you had this big change in operating systems, and it was a pretty big deal. Well, you probably didn't notice so much as an adult the shift from single core computing to quad core computing to multi-core computing. It happened. It kind of happened in the background. It was there. In aviation, this is a really, really big deal. And as chip providers are not pacing their technology to the aviation domain, you end up with obsolete parts. And because those obsolete parts have to be qualified for airworthiness, which has really strange environmental qualifications and vibration qualifications that your normal laptop, even your ruggedized laptop, don't even come close to. As a result, the technology is outpacing your obsolescence needs. So you end up with really, really strange decisions in the aviation space. They sound strange outside of aviation. So I mentioned the 32 64-bit computer. I'm gonna mention another one. Use your other hand. Anyone know what a PCMCIA card is? Right? Okay, we're down to three, right? So PCMCIA cards went obsolete a long time ago, but we still buy them in the aviation space because it is so hard and so expensive to qualify a new solution, which is basically just a USB card, right? You can't get that new technology into the aviation space because the airworthiness qualification takes so long. So you have to not only keep pace to that evolving threat environment, you also have to change to keep pace with a rapidly evolving commercial technology environment. And so those two things have created an inflection point. But you add to that the cost constraints. You can't just throw money at this problem. We're not the Air Force. And I say that as an Air Force veteran. So all love to my flying friends. But the idea that you recognize that I had my first program manager in the Army said to me that 3,000 of any number is a big number, and so our issue is the fleet size of Army aviation versus the technological advancements. So you can compare the very few exquisite systems in an Air Force F-35 or a next generation bomber versus the amount of money that goes to that program, and rightfully so for the capability it brings, versus changing a $500 part times 3,000 Black Hawk aircraft, and you end up with a really big number for a very unsophisticated part. So you add to the financial constraints. You can't even do sometimes very obvious modernization activities because of the size of the fleet that you're addressing. So all of those created opportunities, as well as the introduction of the new Future Vertical Lift platform, to look at the portfolio holistically, to look at modular open systems, not just on an individual system by system basis, but across the fleet of systems for what we're trying to accomplish for aviation writ large. And that led to a reestablishment of business objectives for PU aviation, for affordability readiness, capability enhancement. And these are all business decisions that leverage the technology, but they're about how the business itself operates. Next slide. So I spent a long time on that slide so that I could set up this idea that we could look at the current state of the ecosystem. We said, well, this is where we're going. That's what we want to achieve. We want to get to the future state where we can buy something once and reuse it several times. Similar problems, similar objectives applied through the different and unique lens of the portfolio of PU aviation. And you recognize that to get to that holistic life cycle approach for an individual component that you can qualify and reuse, let's say I've got plenty of solutions out there. They're airworthiness qualifiable. I say qualifiable and not qualified, for the unique airworthiness folks in the room or online who recognize that the difference between something that can be qualified and something that is qualified is that system level context. I'm not qualified until I'm qualified. I'm only part of the way there. So I've got all these solutions that are existing on the market that I could go buy to replace those old PCMCIE cards, but the qualification cost is not worth it, even though the acquisition cost to get that component is easily achievable. And so, in order to get to that future state, we have to address a whole series of business problems. So, we looked at what was in the current state. We said industry is already doing this, especially in the automotive industry, and commercial aviation industry is trying to get there. So, there are new standards like DO 178 that allow you to leverage auto-generated code and trust the code, so that you don't have to manually inspect every single line of code like you would have to in traditional airworthiness processes. So, we look at the industry standards and we look at the industry state of the art. We also look at the development of new standards, the future airborne capabilities environment, the sensors open systems architecture environment, the hardware open systems technology environment, or as you probably know them, FACE, HOST, and SOSA. We also looked at the variety of different engaged activities. So we have open architecture integration labs. We have open testing opportunities that are happening with Army Futures Command. We look at the exchange of digital information and all of the things that were talked about earlier for getting some of the models out of one tooling environment and into another tooling environment, assuming that I have the right level of alignment of technical data between those models and that the same level of fidelity and the same ontology was used between the models. So we call that our architecture collaboration environment for just the connection of the tools themselves, but we also have to do all that ontology work, and we accomplish that through an architecture collaboration working group where we bring industry in, and we have 700 industry members that participate with us as we review these architectural models and ensure that they're speaking the same language, that the models have a reasonable chance of being integrated together, that we're explaining the same types of data. And so, along with all of those things, we're also looking at the next generation cutting edge technology from S&T through a variety of efforts there. And the PU Aviation approach said we need to be able to operationalize all of those things that exist in the current state and put them into a transformational process that changes the way we do business so that we can realize all of that value that exists into the future state. That transformation process ended up with 9 lines of effort. And so you'll notice that those 9 lines of effort, only a couple of them are deeply technical. So the number 2 one, architecture and standards, would be, particularly near and dear to my heart. But also, as you look at not only the technical details of how the architectures work and how the standards align and what parts of the standards you reuse, you also have to look at how you govern the reuse of them, how you are contracting them, how you are sharing software development information and software integration pipelines. If one group builds the software and a different group tests the software, did you get the right data to exchange? Did you procure the documentation for that software at a component level so that you could assemble your system level design artifacts correctly, regardless of what vendor produced that software application? You also have to recognize that qualification material release, I've talked a lot about that. How do the processes inside the business need to get streamlined to improve that qualification process? Oh, and by the way, qualification is only one half of it. You also have the material release process, which is how do I get the part into the logistics trail? And so modular open systems has a hidden implication. That is the number of parts in your logistics system is going to go through the roof, because instead of managing things at the system level where I can buy a whole line replaceable unit and replace that with something else, how do I put a part number on a piece of software that's going to go inside that LRU? And do I have multiple suppliers? And are they all interoperable? And do I leave that to the maintenance technician to figure out, or is there something else that goes along with that material release process? And then, of course, how do we pay for it? So the reason for putting that how do we pay for it emphasis on there is because PEOs, this may be a surprise, right, to people that aren't used to acquisition budgeting. PEOs don't receive money from Congress. PEOs tax programs to get money in order to do their operations. So that means that you have to be very careful when you're trying to do something for the benefit of the entire fleet, that you haven't taken money that they need for their program that was programmed for a specific purpose for a warfighter need. So I know we can do this better if we share these two pieces of information, but that money was dedicated for this program and this money was dedicated for that program, and we end up buying the same thing twice. So in order to do that, we have to have an effective mechanism to do return on investment analysis, and to ensure that we are actually meeting the objective of affordability. Next slide. So part of this is getting the objectives aligned. A big chunk of modular open systems approach is making sure that you're listening to the various different stakeholder needs. So on the far right hand side of the chart, you have Army Futures Command, MOSA initial capabilities or refinement document objectives, and this is I want to write our Army Futures Command desired to write a set of MOSA objectives that were not attached to a single platform so that every platform could leverage them. That creates the requirements basis that we needed to make portfolio level decisions. We tie that to the broader PU Aviation MOSA objectives, or I'm sorry, when you heard what Colonel Breen said before, you recognize that the mission is not just MOSA. The mission exists, and MOSA gets added to the mission to make us more effective, efficient, and credible. So we have to look at the holistic mission of the PEO, and then also look at our transformational efforts. And that last point on the left-hand side, credible to industry, is particularly important because when we do something and we say that the government has the responsibility to make a component level decision, we own a certain amount of risk. We bring a certain amount of risk into the government, and the OEM can rightfully warn us that you're taking on some integration risk away from the OEM, and we can't be certain that a supplier component that you get from just anywhere is going to work in a system that you're asking us to build. How are you going to be credible that that risk is actually realizable and that you've actually reduced it? So I want to answer that question. Next slide. So one aspect of that risk reduction is ensuring that our digital integration of information is correct. And so there's this dance between digital engineering and modular open systems. And part of that dance is ensuring that the kind of information that you are asking for is actually what you need. You can model the whole world. And as I said in an earlier question, all models are wrong and some are useful. And the reason that is stated is because the more that you try and model to get your model to match the real world, the larger and more complex your model becomes. And so as a result, you need the minimum amount of modeled information, and you need it modeled exactly correctly to accomplish the specific objective you're aiming at for each stage of the life cycle. So if you're very early, you need a certain level of information at the logical level. If you're very late in testing, you need specific system level behaviors that you expect in the test. And so you need to be able to get not only your technical data exchange, moving from paper-based to digital ICDs. And by the way, what's the standard for a digital ICD, right? Where are we going to get to the place where we can say, I would like you to deliver me a model-based interface definition for a specific kind of thing, and here's the right format for that. We can't just lean on the existing state of standards for that, as well as the recognition, as I mentioned before, from the airworthiness perspective, I need to get to modular technical data packages. So one of my experiences, this is going to the comment you made earlier about moving from steam gauges to glass cockpits. We procured a modular open system on one of our programs, but we procured it as a complete system, right? With one program, we paid one vendor to build us a set of modules and integrate them, and we recognized that we never asked for documentation on the individual modules as severable parts. So what we got was a technical set of modules that were highly interoperable and that could be moved around, and we got everything we wanted technically, and a large single software development document. And it wasn't wrong. We got exactly what we asked for. We just didn't realize at the time that the modularity of the technical data package is going to be equally, if not more important, for achieving our business objectives as the modularity and the standards at the system level itself. So what we've come up with is a new approach. We're calling it component specification model, but this is actually, that's just the tip that is actually seen at the industry edge of a whole architectural process, which leads to the definition of a component in a model, so that the specification and the technical data come at the component level, so that you can integrate these components together virtually into your system and ensure that multiple programs of record can leverage the same component specification model, and ideally give supplier choice to the program managers for whichever program it is that happens to buy the latest widget. Going back to my PCMCIA and USB memory card example, if we get the component specification model right, we will be able to assemble the airworthiness artifacts, the qualification artifacts, the contracting artifacts correctly to allow any particular program to procure a solution and ensure that we can use that solution again across the fleet. Okay, so I mentioned our work with industry. One of the examples of that is working with the Vertical Lift Consortium to be able to take those component specification models, those digital exchanges of information, those definitions of ontology, and ask industry a question so that we can get a consolidated industry response. It's rather challenging if you've never done this or worked in a program office. It's rather challenging to ask a question to, big air quotes, industry. And the reason is because industry is represented by an amorphous group of companies that range from small garage shop software companies, services companies, architectural companies, research companies, supplier companies, sensor companies, hardware companies, and OEMs, right? And integrators and everything else in between. I'm sure there are companies out there that do things that I can't even imagine for the Department of Defense. And so how do you get a consolidated industry response? Well, that's actually really challenging. The leverage of a cooperative research and development agreement with a consortium-based entity that's specific to the aviation domain creates a powerful opportunity to say to the consortium, what is the answer to this question? Go get the right kinds of people together to answer the question as it relates to whether it is flight control computers on the one case, or survivability equipment on the other case, or maybe safety equipment, or maybe it is radios or mission equipment. And so the ability to leverage that resulted, one of the examples of that is a task to the Vertical Lift Consortium to identify the correct way to create a digital backbone on the aircraft that would separate the air vehicle and the mission system effectively, so that we could get to something very similar to what was mentioned in the ground systems, and the idea that you're going to buy the platform and then add the stuff to the platform to get to the trim levels. I wish we'd thought of the trim level concept, but it just, bonus to you. Anyway, the idea that that we'll be able to separate the mission system from the air vehicle when we have traditionally only purchased complete integrated weapon systems required that industry consolidated answer, and we got a very effective response to that through the Vertical Lift Consortium. Next slide. So the question then becomes, how does that apply to what you're here for this standardization processes? Well, one aspect is that when outside of the room of people who are experts on standards, when you talk about modular open systems, the typical audience member of that will say, what is the standard that you use for MOSA? What's your MOSA standard? And to an architect, you recognize that that's like asking, what's the standard for your car? Well, are you talking about the standard that I use for oil? Are you talking about the standard I use for tires? Are you talking about the standard that I use for air filters? I mean, there are so many different standards that apply because they're domain specific. They apply to a specific problem. And in fact, a really, really good standard should tell me exactly how I can solve a particular problem with an elegant, simple, common solution that benefits suppliers on both sides of a common interface. And so the more generalized a standard is, the less useful it is. And so coming up with an idea that you're going to have one standard that solves the modular open systems approach answer it's just it's nonsensical in some ways. However, it is attractive in other ways because you recognize that aviation domain problems are different from ground system problems. So if you back up, to the program I started with, it was the Future Airborne Capabilities Environment, or FACE. Well, you might have noticed that my friends in the PEO ground combat systems are using the Future Airborne Capabilities Environment standard on their ground system for certain software layer definitions. When we use the standard for the thing it was designed for, we recognize that aviation or ground domains start to fade into the background, and we're looking at whether or not it's a computing standard, whether or not it is hardware or software, whether or not it deals with flight safety criticality or mission system criticality, whether it deals with networking, and we apply the right standard at the right time for the right reason. Well, so with the standards alignment, we also have not only those technical standards, but also process standards. We also have fit for function standards, like the way that I get something on a display. How do I get information on the display? You mostly have recognized the infotainment system versus the digital dashboard in your car. If I want to get a master caution and warning on the digital dashboard, that's a lot different than getting my moving map. As you're thinking about aircraft, right? If you've ever had Google or Apple Maps crash on your way to the airport, which I won't keep anybody from, but if you've ever had that happen to you, you recognize that you can still pretty much drive safely, right? If you're on final approach in inclement weather with people shooting at you and your moving map dies or some other critical navigation feature, that's a bad day. So you want to ensure that you're solving the right problem the right way. And one of those that's not obvious is, how do I get a piece of information up to that aviator on the same piece of glass without causing a potential problem for all of their other flight safety critical systems? And so we leverage a different standard for that. The commercial aviation industry solved this problem a while ago with Airing 661. So we're trying to figure out how to pull the right standards to solve the right problem at the right time, and that's a business approach. And so what we need in order to do this correctly is not just a new standard or even a set of standards, but it's guidance on how to apply those standards for the particular problems consistently across the portfolio, so that program managers don't have to guess, they don't have to reinvent the wheel, they don't have to write new requirements, they don't have to reinterpret those requirements, but that they can pull that information from the digital design repository and digital ecosystem and effectively apply them rapidly to solve the problems they're presented with. Next slide. So one of the ways that we've demonstrated this is through a series of open system architecture demonstration events. We've done this at the FACE TIM. We've done this at the SOSA TIM. We've done this at the industry-wide Quad A event, where a lot of the industry folks will get together and they put together very large, impressive booths about what they're doing. And what we do is we bring all the vendors and we say, hey, if you want to bring something in the Army booth, bring us the component, bring us the technical data, let a group of Army contracted folks, or maybe even Army pure civilians, let somebody who wasn't the designer go integrate that into a system and prove that we can eat our own dog food. Let's prove that we can do this. And we've done that successfully with increasing levels of complexity since 2016, when we really started this. There's a public distro website. You can go get additional information about what we've done in our open systems demos. And the primary reason, this goes back to the first thing I said in my slides, is that we are driving towards reducing real risk, so the program manager doesn't have to assume that a bunch of engineers sitting in the room thinking about the way that things should work in an ideal state have given them a risky set of models and a new approach to contracting. Instead, what we want to do is prove to that program manager that using modular open systems approach actually reduces the risk on their program. Next slide. This is even true when we get to foreign military sales and when we get to international collaboration, because we recognize that a lot of those same problems apply in FMS cases. And because we're doing it in an open way, it allows us freedom to be able to create cases where we can say there's a US only capability. Well, guess what? That's just another application of our MOSA principles. We recognize that that has actually become a critical part in a number of collaboration events that we've done. And we've actually taken a UK component, brought it to the US. We did this in 2017. We brought a UK component developed to their open architecture standards, which are different than ours, to their airworthiness standards, which are slightly different than ours, to their qualification and material release standards, which are completely different than ours. And their contracting strategy is nothing like ours. So in all of those cases, we wanted to say, what's the minimum set of specifications we need to be able to share a component so that I can sell you a US platform and replace it with you can take one component out and replace it with a UK developed component, or where I can buy a UK capability and put it on a US system, or whatever the particular use case is. And so the alignment of multinational open systems architectures specification was a result of that project. We never turned it into a standard because we couldn't quite figure out how to get it into a standard or what the standards body would be for it. So we just wrote it as a specification, got it published, got it publicly released, and moved on, right? But the idea is that this kind of speed to collaboration is really what we're all about, and we're seeing it affect everything that we do. And I think that's my last slide. Thank you.
Thank you. I have to say I wrote some notes, so thank you very much. I would like to just say a few words before we open the floor to questions. Most people think of standards as it's not very sexy, right? It's not something that a lot of people say, "Oh, that's what I want to do for a living," right? But it's critical. It is absolutely critical for implementing MOSA. It's absolutely critical for doing good systems engineering, and it's absolutely critical for having interoperability among systems. And without the work that the folks in this room do and other folks do on standards, we wouldn't be where we are today. So these are some very difficult problems that these folks and other folks are working on, and is enhanced by the work that is done on standards. So I just wanted to throw that out there for folks before I open it up for questions. So does anyone have any questions?
Yeah, yes. Good afternoon. Very impressive. I wish you all the best because we are all counting on it. Back in the 90s, there was an organization called the Integrated Avionics Working Group, which was designing a suite of really cutting edge avionics for the A-12, RAH-66, and the Air Force Advanced Tactical Aircraft. I don't even know if we got a type designation. Very wealthy programs crashed and burned. At the same time, the Joint Aeronautical Commanders Group, which is now the Joint Logistics Commanders Group, said, "This is great. Let's try something similar for the poor programs, fielded programs." They didn't crash and burn. It never got off the ground. No one paid the fuel to fly. I understand that open systems architecture and plug and play is really advanced a long way in the last 30 years, but what's different now that didn't succeed back then?
Well, I can answer a little bit. And the point you bring up is a very valid point. Like, why is it going to work this time? Is it just going to crash and burn? And I think that's a very good consideration. And even on like when we think about OMFV, do we think we're going to get all of this on OMFV? You know, given our current state, probably not. But we're going to get a lot closer than what we are. There'll probably have some trades that have to be made, but we will not make those willingly. Hopefully, we don't have to make them. But the other thing that, from my perspective, that I'm seeing in like in leadership is like even this the idea that even the fact that we even did this architecture effort to me is different because even before like even if you talk about the senior leaders, do they even talk about architecture and standards? So even their perspectives have changed. They realize that the reason we're in the position we are is because we haven't defined our architecture. We haven't embraced the standards. Everything's unique. We have to do something different if we're going to change. So um, whether or not we succeed, I guess we'll see. But it definitely is. There's a different view of it from the leadership levels.
Okay, great. And I'll follow that up, especially given your comment about the avionics aspect. The JIWIG was very very much focused on joint interoperability. So I'm going to give three things that are different. Between what we're doing now and what the JIWIG and some of those spectacular failures of programs may have demonstrated in the past. And so, unlike racing, if anyone's ever watched NASCAR or any other kind of race, when the crash happens, everybody like sits forward in their chair. When a program crashes, nobody wants to watch it. No, nobody wants to watch it when a program ends unsuccessfully. And so we want to learn the lessons from previous programs without repeating those lessons and without getting too close to the good things that they did, without calling out that there were a lot of really good things that were done in the past. So thing one that's different, it is not a joint program. So the idea of a large, very complicated, very well orchestrated joint program to get to common avionics doesn't presently exist the way that the JIWIG was envisioned. Now, there instead you have a lot of working level people who have a day job, who are passionate about seeing a change, participate really because they have something to do, but they still think it's really important to go participate in a standards body, and they think it's really important to go participate in the MOSWIG, and they think it's really important to go do some of these open architecture demonstrations. And that passion that has moved throughout the rest of the organization is driven from a grassroots level, not a top-down joint level program. So that's one thing that's different. The second thing that's different is that the ecosystems that support the ability to do the architectural transformation have radically changed. I mean, the ability to access digital engineering information, the ability to do open architecture integration. I mean, even from the airworthiness perspective, the fact that I can do DO 178 level C, or I'm sorry, revision C, DAL A, auto-generated code with a tool qualification level of 5, which means I don't have to manually inspect the software after the fact. That didn't exist when the JIWIG was invented. That was a new revision of a commercial standard that was driven by aerospace technology changes. So that whole ecosystem has enabled the execution of a vision that might have been a good vision 2.5 decades ago, but that didn't have the tooling or standardization support that it has now. That's the second thing that's different. And the third thing is different. For this one, I'm going to leverage, I think, a butchered quote from maybe Winston Churchill. And I won't try and replicate his accent when I say it, but it was in World War II, and they recognized that they were having a problem that they could not solve by throwing money at it. In fact, he said, "Gentlemen, we are out of money. Now we must think." So the fiscal constraints prevent us from solving this problem with a large, expensive, elegant solution. Instead, we have to come up with elegant, inexpensive, affordable solutions that actually work.
And I'll just add to that. It's scary how much we are on the same page. That Churchill quote was at the top of my response as well. We're out of money and now we must think. So absolutely spot on, John. Looking forward to collaborating with you. I like your quote sources. Yeah, absolutely. The other two things that I'll kind of add on to that is since we're out of money, and the modernization problem isn't just like a modernization of, hey, a slightly different thing. We're entering an entire new age in the history of mankind. We're moving out of the industrial age and we're moving into the data age. So modernization isn't, well, we're going to put on a more powerful cannon. No, we have to restructure the entire way we do business. And because we're in such an inflection point of modernization, moving in out of the industrial age into the data age, modernization is vastly, exponentially more expensive than it was before. So the Churchill quote is very apt to that. Add on to that something we've heard about over the last couple of days: great power competition, and we have an immense amount of support from leadership to succeed. And what that support from the leadership allows is the grassroots groundswell that John mentioned to actually succeed this time. You know, there's kind of the old joke in the programmatic arena. I'm sure it exists everywhere else. The leadership's got their vision, they've got their thing that they want to sell, and they want to move forward. And the engineers already know how to solve the problem, and the logisticians know how to solve it. they just never get the opportunity to get their voice heard and never get the opportunity to help succeed. They just have to go kind of carry out the orders from on high that are pushed down to them to implement. And from my perspective, can't speak for the whole DoD, but that's just not the case anymore. We've burned a lot of modernization money. We've seen, and I won't list them to protect the innocent and guilty, but there's been modernization efforts over the last 10 years that have failed miserably. And we realized, hey, that approach didn't work. Let's take a step back. And a promising thing is like Alan mentioned, we're a fairly new office. They realized that integration from out of an office in the Pentagon for the entire Army probably isn't a great one-size-fits-all path forward. That they need to push those integration offices down to the different program offices, PEOs, to get after that. So I think we've got a lot of good momentum behind us, and a lot of chance for success this time around. Long answer to a short question, but it was an important one.
Thank you.
I'm sorry, I saw your hand first.
Hopefully this one will be short. But did I turn? I turned it off. Okay. Given the nature of change, having experienced kind of Army change where leadership changes, and this could be at any level, right? And it completely, they come in and they wipe out the whiteboard and start all over again. And we're all kind of going back in, looking at the whiteboard, going, is there anything left? What can I find from this last? Do you see anything within this kind of architecture and this kind of implementation that can help sustain that even when things get renamed, rebranded? Because there's a lot of rebranding that seems to happen. Maybe I just haven't been around long enough to understand it, but it does happen that things get rebranded. So from the work that's going on, will we be able to leverage what's being done, even if things get shifted around, so that you can have some kind of sustainability of things that are still in motion, if that makes sense?
Sure, I'll take a stab at that. So you're basically kind of wondering like what would maybe impacts of like leadership changes if they change the whole program, how does that impact? We kind of resilient against that. Um, so yeah, one thing that just how the architecture is. I mean, I personally can't see how you just totally unless you throw the whole thing out, which that'd be a pretty drastic change. I don't see that happening. But the other thing is like we're not creating anything new. We're leveraging existing standards wherever they are, and like we liberally steal from aviation wherever possible. So even like we've had some syncs with them. So even syncing up with the other PEOs and using the same standards, not reinventing your own thing. I think it's almost like a coalition, and it's really sensible that why would you break it up if everyone's kind of moving the same direction?
I'll follow that up with with a note that I need to steal your graphic. I've been envious of your graphic for quite some time. Really like that graphic. Anyway, the thing I want to add to what was stated, absolutely true in every respect, is that you've built something that is resilient to change because it is good. And because it is good, it's really hard for somebody to come in and replace it with something that's ad hoc and not very well thought out. That doesn't completely answer the problem that you've talked about, though, because there's a hidden little gem in your question that may not be obvious, and that is that the Army recognizes that command and control is shifting. It's fundamentally shifting. And there have been some really great briefs that you can go watch on YouTube from senior Army leaders that talk about this. But it's about decentralized command, moving command down to the lowest possible level so that decisions are at the point of relevance, which means that you're actually empowering somebody at the program office level in that leadership role to make good decisions. And so that means that you're bringing somebody that's even less experienced They don't have years of product line engineering understanding, and they're coming in as an O4 or an O5 to a program office with a massive problem to solve and an emerging threat, and it's got to get in the field right now. They're going to look at their senior engineers who have been there for a while and say, how can I make this successful? But the other part of that, the hidden gem part, is that they recognize that we have to be adaptable to leadership changes because those leadership changes are driven by environmental factors that are the real world. That inflection point that causes us to need that modular open system, the ability to change rapidly, is the very thing that our infrastructure enables. So when the commander changes their mind, we have to assume that they're changing their mind based on conditions that are existing in the real world, and we want to be responsive to that. So we're trying to create an infrastructure that actually enables that leadership change, that enables that new leadership direction without disrupting the fundamental core of what we're building.
I'm going to take a stab at this one as well. One of the benefits of MOSA that some folks don't realize is, yes, it could increase your supply chain, but it also can reduce it by allowing a common parts to be used among multiple systems. So, and one of the benefits of that is that if your mission changes, instead of having to field an entirely new system, you can field part of a system or upgrade your system easier to help go towards that new mission. So it reduces, it may not initially reduce because there's a lot of thought in how modular you have to be and how you are going to be modular when you're first putting out these large systems. But in the future, when you have to make changes to it, should reduce that time frame significantly of putting out that new capability. So that is a benefit of MOSA that that is coming, and not quite here yet, but it is coming as these systems are fielded.
I'll add on to Nadine's comments just quickly with a bad analogy that I'm full of bad analogies. So if you're looking for one, come talk to me, and it'll first 30 seconds I'll probably give you a new one. But I talk a lot as I talk about the trim levels and what you were talking about with mission changes was I'm trying to explain the trim levels and what we're trying to do. I talk a lot about Jeeps, and you can buy a Jeep Rubicon off the assembly line, but the Army can't afford a Jeep Rubicon for everybody, and it comes with a ton of capability. The Army can afford a lot of Jeep Wranglers, and with aftermarket components and with a standardized architecture and way of doing business, you can add KC lights, a snorkel kit, some different shocks, different things on that, and you can build that initial inexpensive Wrangler that you bought off the assembly line, and you could surpass an off the assembly line Rubicon capability at the end of the day, and that's one of many bad analogies I'm full of.
I'm stealing it.
Hello. I wanted to give a shout out to Dispo. Thank you for this title for this panel, Architecting for Change, because I do think the speakers have adequately addressed the topic. Thank you, John Stough. Thank you, everyone. POGCS. We've worked with Macam before in the past. So my name is Monica Forey, with OUSD R&E. But with the MOSWIG, I really believe the collaboration that's happening across the services, tri-service efforts, as well as the consortiums. I think the difference is that you've got not just communities of interest or coalitions of willing, but you've got the leaders that are at the services actually championing standardization efforts across consortiums. So I really have seen a big change in that. But I want to say that the discussion about the trim levels and definitely John Stough about the initial concept refinement document, to me, those are examples of now architecting for change, looking for a new way of addressing the way we do business. And so, John, I wanted to ask a question about the MOSA Conformance Center, one of those lines of effort that you guys have with PO Aviation for your transformation effort. How do you see that working, the conformance? Because I know going across platforms and enforcing change across the PO can be a challenge, but I saw that and I wanted to ask that question.
Yeah,
Thanks.
great question. So this is an example of adapting as we learn. We originally called it the MOSA Conformance Center and we recognized that that had an implication that it was a thing, a lab that existed, and we changed that. And I may not have updated the slide. The slides are long time public release, and I don't have graphic skills, as I've already pointed out. It's now the MOSA conformance capability, which leverages a whole series of labs that already exist, that already perform part of the total function. And so, in the same way that you want to apply a standard to the particular problem domain that the standard was written for, you want to measure conformance at the level of the problem that's being addressed. And so, one of the issues that happens is you try and if you try and make everything conform to exactly the same solution, you end up with nobody can afford the Jeep Rubicon. I told you I was going to steal it. But the idea is that you want to allow customization and modernization and modification at an individual level. So what are you conforming to? Well, part of it is you got to get your conformance down to the minimum viable product level of thing that you're trying to measure, right? I'm conformant. So this is a thing I had to learn. I'll use the FACE technical standard as an example because it's really well published and has a really, really good conformance program, but its conformant is at the individual software application level. There is no such thing as a FACE conformance system. There is only a FACE conformance software application, and that's a small subset of a total system. In fact, it's a small subset of a subsystem, right? And so you get conformance at the level at which the standard was designed to measure conformance. But when you're looking at conformance to modular open systems approach, you're talking about a business conformance. Conformance to, did you answer the business question? What's your return on investment? What's your speed to field? Did you consider commercially available sources? And it becomes a rubric of the kinds of questions that go from top level business concerns all the way down to that component level measurement in the lab.
So something's been keeping me awake at night. So I'm Robin Brown. I'm the obsolescence lead for DoD and also the parts management lead. So I think that I've identified a gap in DoD, but I hope you guys tell me I'm wrong. So you were talking about modular open system approach. We talked about digital engineering. We talked about, new missions and using MOSA for that, for that reason. But what about for obsolescence? So DMSMS, diminishing manufacturing sources and material shortages, and I'm up next, so please don't leave the room during break, is inevitable. So it's going to happen. So what I've been preaching for the last several years is not only pick your parts more wisely and build MOSA into your systems, right? Because that's going to help with DMSMS and obsolescence. Build those DMSMS resilient designs, right? And when you can't, plan for obsolescence because no matter what's going to happen. So what about the planning piece? That's the piece that I have yet to find good policy, good guidance, or even a belly button for. How do you do a really good technology roadmap in the government or a technology refresh plan? I have asked, there are several, just a few that I found, and maybe I'm hopeful that you guys have a way to do that. But I've queried many program offices across DoD, many organizations. I've asked industry to give me examples. I feel like if we don't plan that middle piece, we're never going to succeed. We're never going to use what you guys are creating, and we're always going to have obsolescence issues or, so what do you guys think about that?
All right. So first of all, thank you, and I hope everyone. I will echo everyone. Stick around for her presentation. So I'm gonna take your question and turn it into a positive. I'm gonna say yes, we are always gonna have obsolescence, and from a MOSA perspective, that's a good thing because I see that as an opportunity as much as I do as a challenge. The fact that we have historical record of obsolescence causing lifetime buy. Which is particularly an issue in the aviation space for the reasons I described before. I don't know how much of an issue it is in other places, but I think in general, lifetime buy is going to affect any particular obsolescence issue. I know that the supplier is going to go out of business, so I'm going to buy everything they have on their shelves and I'm going to put it on our shelves. And I don't know if I really need it or not, but because the source is going to go away, I got to get it. Instead, what we're going to do is leverage an architectural principle called separation of concerns. And the basic principle is simple, right? And that is that I want to ensure that the key interface is determined at the point where severability between two different concerns can occur at an effective level so that they can change independently, right? The whole point of the standard is to identify the mechanism by which those two independent changes can be separated that allow me, when an obsolete part happens, to replace it with something new. And so, one of the examples that gets floated, it's not a great example in deep, complex technical systems, but it's a really great example for illustration of the point of obsolescence, is the light bulb, and the mechanism that has used to screw a light bulb into the receptacle, right, or a power outlet plug. The first time this was used it was actually a two-star general that used the analogy. I cringed in my seat. I'm like, no, that's completely. And then the more I thought about it, I was like, he's right. The issue is that the interface definition, if we do our job correctly and we identify the modularity correctly, that you can change the technology on the other side of the interface without affecting the interface and the data exchange for everything else that's dependent on it, which means that when the old style of light bulb goes out for environmental concerns, or filaments are not there anymore, or they're not making that kind of glass anymore, I'm replacing with LEDs, new technology is there with better lumens, whatever it is, doesn't matter. The idea is that the interface has separated the concern sufficiently so that I am not dependent on obsolescence driving my technology decision. I am now driving the technology decision independent of obsolescence and using the obsolescence as an opportunity to get technology refresh.
Agree with part of that, but I still feel like obsolescence should be running the show. So it's going to happen. So why aren't we doing technology refreshes on a regular basis like we do with software? Or why aren't we thinking about maybe for our critical systems or things that, because we know, especially for microelectronics, right? They're going to be obsolete in 18 months. We know that. So why aren't we, you know, factoring that in doing technology refresh on a regular basis versus waiting for obsolescence to occur?
I'll keep going. So part of it is the system level integration and qualification aspect. If parts are obsolete in 18 months, are you aware of DoD contracts that can be levied fast enough to keep up with that pace of change? So contracting is half the problem, or I should say, the concern of the contracting side to keep pace with rapidly changing technology is part of the issue. The other side of the issue is the discussion from the previous panel about complex integrated system design in total product delivery from an OEM. And so, because both of those, and I won't really call that the contracting side, that's the delivery side, right? How do you write the contract and get it on contract fast enough? And then how do you allow the flexibility for an OEM to be able to change their mind or to even replace a subsystem supplier with a new technology? So those are business challenges. And again, from a technology perspective, we want to enable the interface definition. But you're right, it didn't address the business strategy side of that. The business strategy is to be able to recognize that there is still a separate contracting issue, there's still a separate qualification issue, there's still a separate integration issue, and I need to be able to deal with all of those things in my total overall approach. And so I think this is where Ground Combat Systems is a step ahead of PU Aviation. They have a program office for integration. We don't work quite that way, and part of that is the difference in the way that systems are constructed, and part of that is they're taking a different part of the elephant. I think somebody else's analogy from earlier today, but the idea that you have a business side to that obsolescence as well as the technical side is also true. So.
Yeah, and I guess the only thing I have to add to that is I can't speak to why it hasn't been gotten after in the past, but I agree 100% with John that we have a great opportunity to more closely tie the two going forward. Every obsolescence issue should be not seen as a delta, but it should be seen as an opportunity to do modular open system architecture, pull that out, put that in, and go forward, and have it be standards based. So nothing more to add, but agree completely.
Yeah, just one final comment is, yeah, I agree with that concern, and why we're not doing that is because every system's unique. It's like super expensive. We don't have the IP. So that's even why we're doing this is so we don't have that problem in the future. But yeah, in the near term, we have to deal with the obsolescence. But once we have this implemented, then we're not dependent on any single one component. You can switch it out. So,
I don't want to pile on here, but just because there's a new chip that comes out doesn't necessarily mean that the old chip is going to be stopped being produced, or that it needs to be replaced. As an engineer, I think I can harass engineers a little bit by saying that we will always want to do more testing and more engineering, and sometimes you have to stop us to get a product out into the field. And there are parts that will go obsolete during some of these long development, not even after, during. And so you can chase your tail constantly upgrading that part and going through testing all over again and going through development all over again with the new part. So you have to be careful about and really think about what parts do you have to replace, not just because they're obsolete, but because you literally can't get them anymore before you start changing them out. But the MOSA should help with that because at least you then don't have to replace the whole system. You can replace the individual components. Secondly, I have to agree with something that I think you're implying but didn't come out and say. 70%, they estimate 70% of the cost of a system is in the logistics chain. And I do not think that we spend enough time talking about the logistics chain in DoD and paying attention to it. Partly because of the way, in my personal opinion, the way the money is divided. You're paid in a PEO office to develop a product and get it out to the field. You're not paid for the logistics chain. That's a whole separate pot of money. So there's not that incentive there to think about it as much as you probably should. But hopefully, people are starting to take a little more attention to that. I've heard of, there's a new term for it, but spiral development is what it used to be called. That they're starting to go down that path of thinking about when do we want to upgrade parts in the beginning so that they have that plan all the way through. And MOSA is also helping that as well. So thank you for the question.